All right, guys, so before we get started, are there any questions on any of the assignments so far? Questions on the homework? No questions so far? All right, guys, so what we're talking about today is we're dealing more with matrices. Now, the first thing we're going to look at with matrices is adding and subtracting matrices, adding or subtracting two or more matrices. To add or subtract two matrices with the same dimensions, add or subtract their corresponding elements. Add or subtract their corresponding elements. Now, you don't have to write this down, but when we look at two matrices and we're adding them together, highlighter, well, A is in the top left, E is in the top left, so we add those two together. B is in the top right, F is in the top right, so we add those two together. C is in the bottom left and G is in the bottom left, so we add those two together. And D is in the bottom right, H is in the bottom right, so we add those two corresponding ones together. So the ones that match up, we either, if it's saying add, we add those together. Same thing, exact same thing with subtraction. The ones that are in the same spot, we subtract from each other. And that's it. Now the one big thing with this here, let me pick this. The sum or difference of two matrices with different dimensions is undefined. So if they don't have the same dimensions, sorry, if I don't put this map back out, I'm going to trip over it. If the dimensions aren't the same, we can't add or subtract. That's all that's saying. So if one of them's a 2 by 2 and the other's a 3 by 3, it does not work. The dimensions have to be the same for us to add or subtract. Questions on this here? No, but I mean, the main thing with all this here is if they're the same dimensions, we can add or subtract corresponding elements. So when we look at this one here, what are the dimensions of these two matrices here that we're adding? Right, so it's a 2 by 2 and a 2 by 2, yes? So this is a 2 by 2, this one's a 2 by 2, they're the same dimensions, yes? Since they're the same, we can add. And exactly. Also, so we would do 2 plus 1. Yep, top left, top left. Then we would have -1 plus 2. And the next spot we would have, and lastly, 0 minus 2 or 0 plus -2, both are the same thing. Now we can just simplify those. 2 plus 1 is 3. -1 plus 2 is 1. 3 plus 4 is 7. And 0 plus -2 or 0 minus 2 is -2. And that's it. Questions on this here? Same thing is true with subtraction, but instead of adding, we're going to subtract. So are these two matrices the exact same? Almost. 3 by 2, because the first one is a 3 by 2. The second one is a 3 by 2. So they are the same, so we can subtract. So we're going to say 2 minus -1. Then we'd have -3 minus 2. Then we'd have 5 minus 7, 4 minus 8, -2 minus -5, and lastly 8 minus 6. Thank you.
Addison Jones, please come to the office. Addison Jones, please come to the office.
So our first one, 2 minus -1, the same as 2 plus 1, which gives us 3. -3 minus 2 would be -5. 5 minus 7 is -2. 4 minus 8 is -4. -2 minus -5, the negative makes a positive, which gives us 3, and 8 minus 6 is 2. Questions on any of this here? No. What were you going to ask?
No, we're about to get it.
Okay.
I was just going to ask if you could do it a third time.
Okay. Any questions on this one here? So, are these two matrices the exact same? No. So, can we perform this operation?
Yes.
No. So, each number is an element, yes? Is 0 technically an element? Yeah, we can have a value of 0, yes?
Yes.
So, if I'm adding zeros, am I changing the matrix?
No.
Because is this one here the same as 6, -1, 0, 2, 7, 0? So what was the dimensions of the first one? 2 by 2, yes? This one down here is now what?
2 by 3.
I changed it, didn't I? So these here are actually not the same. Because I'm adding those elements in, I'm adding a new dimension, I'm changing the matrix itself. Yep, this one here is undefined. Yep, because the sum or difference of two matrices with different dimensions is undefined. Yeah, because we can't add anything to it because we're actually changing it. Because if it was taking the place of something, that's fine, but here we're putting more information into it. So it doesn't work. Any questions on this so far? So if I said second matrix, because again, in here we can put matrices in, yes? So let's look at the next one. So we can say edit. Well, both of these matrices are a 2 by 2, yes? And the first one is -1, 7, -1, 7, 5, 3. So I just put the first matrice in that problem into the calculator, yes? Now we can put the other one in. So we can go second quit, second matrix, over to edit, but this time I'm going to go down to B, because we're wanting to deal with two matrices, yes? And we can define this one here, which is a 2 by 2, which we have 6, -4, -8, and 2. So I've just defined the two matrices that we have in the next problem, yes? So we can go second quit. Now the first matrice that we're dealing with was defined as what? Second matrix, matrice A, yes? And then what did we do? We added to it matrice B. So I can go second matrix. So again, what we did for this here is I defined both matrices. One is A, one is B. And then once I finish defining them, we can go second matrix and use this first row to pull them back up. So I defined A first and put it in, and then B. Questions on this here? I mean, for these here, it's not too, you're not really saving too much time based off actually just doing the calculation. And we can do another one. Because if we did this by hand, there'd just be -1 plus 6. 7 plus -4. Yeah.
Like to the problem, I don't know.
Yeah, it would actually answer the problem, because if we did this by hand, negative 1 plus 6 is 5. 7 plus negative 4 is 3. 5 plus negative 8 is negative 3. And 3 plus 2 is 5. And the calculator told us that it's 5, 3, negative 3, 5. Let's look at one more, and I'll do it a little bit slower because I know I ran through that quickly. Let's look at this one here. So we'll look at this one with subtraction. So if we want to do this one in the calculator, we have two matrices, yes? Okay. So we have, now we'll define this one, we can say is A, and this one is B. So in the calculator, we pull it up, we can go second matrix and go over to edit. And I'll go on and hit enter to edit matrix A. Now this time we don't have a 2 by 2, we have what, a 2 by 1. So we can say 2, 1. Now the first number is 2, and the other number is 5. So that's the first thing we need to do is input the first matrix. Now we can go second quit, and then we need to edit the other matrix. So we can go second matrix, over to edit, but this time we don't want to edit matrix A, we want to edit matrix B. And you hit enter. And again, it's a 2 by 1. And our first number is negative 3. And the other number is 0. Any questions on how we inputted the two matrices? We're good? Okay. Now we can go second quit. Now to call the matrices up, well, the first one we need is matrix A. So we can go second matrix, enter for A, because that's the first one we had, yes? And what are we doing? We're subtracting from it the matrix we called B. So we'll say second matrix, go down one, enter, and we get 5, 5. That's it. Because if we look back at this, what we're saying is 2 minus negative 3 and 5 minus 0, which is indeed 5, 5. Questions on this here? Question?
So would I still be able to do, would it be different like if it was a 1 by 2?
Yeah, I mean, if we had a 2 by 1 and a 1 by 2.
Would we still do that? Or would
Yeah, we can still put it into the calculator, but the calculator will throw out invalid dimensions. It'll tell us that, so if I go second matrix, edit, and we could say a 3 by 1. So this is already not going to work. Second quit, enter. Dimension mismatch does not work. So the calculator, even if we plug it in and it won't work, it'll tell us this does not work. Okay. So can we do this one here? Why not? Right, we have a 2 by 1 and a, these are not the same, so this is undefined. Does not work. Any other questions with addition, subtraction? We kind of like addition, subtraction with these here. These will show up on the ACT, can show up on the ACT, adding, subtracting matrices. If we feel comfortable with that, we can look at the next part, which is scalars. So you've probably heard of scaling something, because if we scale it, it's either going to make it bigger or make it smaller. And whatever that scalar amount is, we're going to multiply it by each element in the matrix, by that value. So let's go on and look at the first example we have here. Perform the indicated operation. So we want to scale this matrix by a factor of 2, which means every element inside this matrix is going to be multiplied by 2. So if we wrote this out, we would say 2 times 3, and 2 times negative 2, and 2 times 1, and then 2 times 5, and 2 times 2, and 2 times 0. We're just multiplying everything by 2. Well, 2 times 3 is 2 times negative 2, negative 4. 2 times 1, 2 times 5, 10. 2 times 2, and 2 times 0. Well, that's your answer. And guess what else we can do in the calculator? Yes. So we would add it, multiply the whole thing by negative 3. Add the 2 together. So the first thing we could do is distribute the negative 3. So we'd have negative 3 times 5. Negative 3 times 0. Negative 3 times negative 2. Negative 3 times 4. Now we could simplify this first one here and actually simplify the multiplication. So negative 3 times 5 is negative 15. Negative 3 times 0 is 0. Negative 3 times negative 2, negative and negative makes a, and then 3 times 2 is 6. And lastly, negative 3 times 4 is negative 12. And last but not least, we need 2. Add them together. Negative 15 plus negative 1. 0 plus 7. 6 plus 3. And negative 12 plus 2. Well, negative 15 plus negative 1 is negative 16. 0 plus 7 is 6 plus 3 is, and negative 12 plus 2 is, and that's our final answer. Any questions on this here? You're good? Now, either one of these here aren't too bad. Because number 5, we're just distributing that negative 7. It's not too bad. It's just the multiplication of negative 7, yes? Now, I think we feel comfortable with this one here, yes? Let's look at number 6. But let's look at it on the calculator. Because number 6, we have 4 times the first matrix minus the second matrix, yes? So let's define the first one. So, come back over here. we're going to find this one as A and this one as B. I mean, if we had a third matrix, we could define it as C. I mean, we could keep going on. We can add as many as we want. So if we come over here, we can go second matrix and go over to edit to plug this in. Now the matrix we have, what are the dimensions? 2 by 3. Is that the matrix? I think that looks 3 by 2. No, actually, I'm glad for that, because if we look at the matrix, because I mentioned this the other day, the calculator can kind of tell us if we got it right. Because if I look at that and that doesn't look like the one I have, okay, we can come back and change it to 3 by 2. It kind of gives us a hint. So we can say 3, 5, 4, 2, 0, -2. So we good with typing the first one in? Yes? Now we can go second quit, then second matrix, and go over to edit and down to matrix B, which is another 3 by 2. And this time our numbers are 9, 7, -6, 5, 2, and -3. And we can go second quit. So are there any questions on anything we've done so far? So I'm going to go back to this slide here. So what are we saying? We're taking 4 times matrix A, yes? Because we plug matrix A, that first one in is A. So we're saying we're multiplying it by 4 and then what? Subtracting B from it, yes? This is how we're going to plug it in. So in the calculator, we can start off by saying 4, second matrix A, minus second matrix B, and then hit enter. And that's the answer. Now this is just for me personally, how I see most of these, because basic scalar addition subtraction, plugging it into the calculator really isn't any faster than doing it by hand, using a calculator just to do each one. Would y'all agree with that? When we look at something like this here, 4 times, because we're scaling matrix A by 4 and then subtracting B from it. It takes a little bit longer to do that by hand, especially if we said we multiplied matrix B by 3, or we're doing halves and fourths and different numbers. Then, especially when we're doing scalars on both, it takes a little bit more time to do it by hand, and the calculator can do it just as easily. Questions on any of this here? Yeah. Because with any of these here, because I could say 4 times A plus B minus 3 fourths times matrix C. Because there's any number of ways we can do that. And I just put A, B, and C, yes.
Let's just say the 4 replace the -1B. Could we just do 4 parentheses A plus B? Or would we have to?
Like plus 4B?
Yes.
Yeah.
Just do what you done.
So we could do this here and just say 4 second matrix A plus 4 second matrix B. And we could say 2 alpha y equals enter thirds second matrix A minus alpha y equals enter 5 halves second matrix B. So we can do any combination. It can be any number. And it'll calculate any of them just fine. Questions on this here? And especially once we get to these here, or multiplication, because we won't cover multiplication quite yet. But I could say second matrix A second matrix, I'll need to, there we go. Matrix B, because we can multiply them together and it'll do it just fine. So we haven't gone over how to do multiplication yet, and we won't for this chapter, but the calculator can still do it. So when you take the ACT, even if we haven't gotten to multiplication yet with matrices, the calculator will do it for us. Questions on this here? And that's it. Oh, yep. Luckily, I do have it right here. Welcome. So problems 3 through 6, perform the indicated operation if possible. If possible. 7 and 8, describe and correct the error in adding the matrices. So you'll need to kind of describe what they did wrong and then correct it. And for 7 and 8, they both did something wrong. 9 through 21 on, perform the indicated operations. For those there, so 9 through 15, so 9, 11, 13, 15, they kind of just wrote it out. You'll just do the operation. 17, 19, 21. So it defined it as A and B, and the matrices are right above it. Y'all see that there for 17, 19, 21? So they gave you A, B, and C. For 17, 19, 21, what you could do is just start off by defining in the calculator what A, B, and C are, and then type it in exactly as you see it. Because for like 19, 2 times matrix B minus C. And as long as you define A, B, and C as their actual ones, you just type it in and you're done. And that's it.